Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to start our discussion of trigonometry, which is one of my most favorite topics in geometry, but also in other mathematics as well. Generally, it's a bit easier in geometry, and then students start to not like trigonometry when they move into Algebra 2, pre-calculus, or calculus. But I think understanding and getting a strong foundation now will help set you up for, not hating it when you get to higher level math classes. So we're going to skip the do now. That's a bit of review of altitudes and right triangles, which is what we did in our last lesson. And we'll actually come back to this introduction problem at the end. So after we talk about or after we have a little bit of an introduction to what trigonometry is. So we're going to start with the three big ratios in trigonometry: sine, cosine, and tangent. Now, the first thing I want you to do is I want you to label these triangles with opposite, adjacent, and hypotenuse. So you're going to label the sides of these triangles opposite, adjacent, and hypotenuse. And you're going to use these reference angles for reference. So let me just do the first one for you, and then you can kind of apply it to the second one. So if this is my reference angle right here, A, well, the opposite side, right, is going to be the side opposite of this angle. So, whoops. And you can abbreviate opposite OPP. I know what my hypotenuse is, right? That's got to be the side across from the right angle. So across from the 90-degree angle. And then the adjacent side, or ADJ, is the side that's adjacent to the reference angle, but not the hypotenuse. So go ahead, fill in those sides correctly for the angle on the right. Notice that your reference angle is now B. It's now at the top. Okay, so hypotenuse across from the 90-degree angle, the opposite side across from the reference angle, and then the adjacent side is the one adjacent to the reference angle. That's not the hypotenuse. I find it easier to label the adjacent side last, especially when you're first starting out labeling these sides. So the three big ratios, we call these sine, cosine, and tangent. So the sine of an angle is the ratio of the opposite side to the hypotenuse. The ratio of the opposite side to the hypotenuse. Cosine is the ratio of the adjacent side to the hypotenuse. And tangent, the tangent of an angle is the ratio of the opposite side to the adjacent. And here's essentially what's going on here. You may be saying, what are these ratios? Like, why do we have special names for them? Well, let's go back up to one of these triangles. Let's say that I have an angle, we'll call this angle 31 degrees. Now, if I have another triangle, let's say it's similar to this right triangle, but it's smaller. So similar meaning same angle measurements, but smaller. And let's say I have another triangle, we'll say that it's larger, but also similar. Well, if I take the sine of that 31-degree angle, so the sine of 31 degrees for the red, the sine of 31 degrees for the black, and the sine of 31 degrees for the purple, it doesn't matter how big or small your triangle is, these values are always going to be the same, right? So the numbers for the sides are going to be different, right? And I'm just making these numbers up, right? I would have to use a calculator to figure out exactly what the sine of 31 degrees is. But let's say this is, 2 and 4 for simplicity's sake. So again, the ratio for sine is opposite over hypotenuse. I really got to figure out why that's doing that. So opposite over hypotenuse would be 2 over 4. For red, the numbers may be different, right? Maybe this is 1 and 2. But the value of that ratio has to be the same. For purple, that one's bigger, so maybe we have 3. Oops. Maybe we have, I'll do this inside. What is going on? There we go. Okay. There we go. 3 and 6. Again, which is the same as 1/2. So if you have a right triangle with, if you have a bunch of right triangles with the same angle measurement, right? In this case, it's 31. If you take the ratio of the opposite and hypotenuse sides, that ratio will be the same for all of those triangles. It doesn't matter how big the triangles are, doesn't matter how small. The ratio will stay the same. That's why these ratios are special. Cosine and tangent, they're just different ratios with the same properties, right? Those ratios for cosine and tangent will stay the same regardless of how big or small your right triangle is, as long as those triangles are similar, right? As long as they have the same angle measurements. We're going to continue to talk about sine, cosine, and tangent. This probably still seems a little confusing, right? You probably still don't understand, what they are or why we have them, but hopefully that will become apparent as we work through some application problems. And you really won't have a full understanding of sine, cosine, and tangent until you take Algebra 2, pre-calculus, and calculus, because those are going to look at, some of the other aspects of these. We're calling them ratios now, but they're also functions, sine, cosine, and tangent. So when you really dive into a study of functions in Algebra 2, you'll see another side of sine, cosine, and tangent that we aren't necessarily going to explore in a geometry course. But I guess what I'm trying to say is that these ratios, functions, they are quite complex, and we're just exploring a small part of them in geometry. And you'll continue to build on that as you take future math courses. Big thing to remember now is these ratios, right? What sides am I looking at if I'm going to look at sine, cosine, or tangent? An easy way to remember the sides is to remember this little mnemonic device. So, ka, toa. Okay? You'll notice that the first letter of all of these represents one of the functions, or the ratios, so sine, cosine, and tangent. And the other two letters next to it represent the sides of the ratio. So sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So, ka, toa. That is the mnemonic to remember the ratios for sine, cosine, and tangent. Okay, let's get some practice in. For this one right below, all I want you to do is tell me what the ratios would be. And our reference angle here is going to be alpha. So I want to know what the ratio for sine of alpha would be. I want to know what the ratio for cosine of alpha would be. And I want to know what the ratio for tangent of alpha would be. Alpha, again, just a Greek letter. A lot of times it's used as a variable for an angle. So go ahead, pause the video, see what those ratios would be. Okay, for sine, it's going to be opposite over adjacent. But we should label these sides, right? It'll make it a little bit easier for us. So the opposite side to our reference angle alpha is 8. The hypotenuse is 17. The adjacent side is 15. So sine, opposite over hypotenuse, that's going to be 8 over 17. Cosine, adjacent over hypotenuse, 15 over 17. And tangent, opposite over adjacent, 8 over 15. These ratios will help you solve for missing sides, and that's what we're going to get into next. So let's jump down here. Let's do, I guess we can do a couple of these. We'll do 1 and 2. So we're going to try to find the length of the missing side, or the one that they tell us to. So for number 1, we're trying to find the length of side AB. So I'm going to label that as X. Now notice that they give you an angle measurement here. We're going to use 41 as our reference angle. So before I set up an equation, I want to label the sides based on this reference angle 41. Now you could do it based on this other angle up here, but that's just going to be more work for you, right? You'd have to figure out what that angle is before you were going to use it. So we're just going to use the one they give us, 41. Well, that means that 6.1 is our opposite side, and that means that X is our adjacent. This up here would be the hypotenuse, but we don't need to find it, and there's no number, so we don't really need to worry about it for this problem. So here's what we need to think about. If I'm going to use the 41-degree angle, which ratio uses the opposite and adjacent sides? Think about which ratio uses the opposite and adjacent sides. Well, the answer there is tangent, right? So tangent is the ratio I'm going to use. So I'm going to have tangent of 41 is equal to opposite over adjacent, so 6.1 over X. Now, here's where you need a scientific calculator. You need a calculator that has the sine, cosine, and tangent buttons on it. Maybe some of you have a TI-84. If you do, great. Pretty easy to see where the sine, cosine, tangent buttons are on it. For those of you that do not have a scientific calculator, or if you don't have one at home, maybe you're borrowing the ones we use in school, but you need one at home, you can use the internet to do it. So let me show you. Let me get rid of this real quick. If we come over to Google, and if you just Google scientific calculator, here's the results you get. And you can go to the very first one. It says Desmos Scientific Calculator. Click on it, and it will pull up the calculator that will be sufficient for what we're doing right now. Let me just rewrite the equation. We'll do it over here. So we had tangent. Let's just start that all over again. So we had tangent of 41 was equal to 6.1 over X. And we need to figure out what X is. However, let's first talk about what this thing right here is, tangent of 41. Well, like I said, tangent's a function. So if you substitute in a value like 41, it's going to give you an output, right? So your input would be 41. Your output would be some decimal. This is read as tangent of 41. It's not tangent times 41, right? Think of, like I said, tangent's a function. So think of it as f of x, right? You don't read this f times x, you read it f of x. If I substitute in a number, this is read f of 5, not f times 5. So again, sine, cosine, and tangent, those are all functions. So it's read sine of, cosine of, tangent of. I just don't want you to sound silly when you say it out loud in front of someone. We got to read it like a function. So on your calculator, you have these sine, cosine, and tangent buttons. Now, without going into too much detail, you need to make sure your calculator is in degree mode. So right here, it says degrees. If you're on a TI-84, you would want to click Mode and go down to the third row and switch your calculator from radians to degrees. Radians is another type of measurement for angles, but we haven't talked about it yet. So we're only going to be talking about degrees for the foreseeable future. So if you're using this calculator, make sure this toggle switch, make sure it reads degrees. If you're on a TI-84, go to the Mode button, go down to the third row, and make sure that degrees is highlighted. If you have any questions about that, you can let me know. You just want to, if you're in the wrong mode, you're not going to get the correct answer. So all I need to do is type in tan of 41. That is going to give me a decimal, which I can rewrite in my equation. Now, for this class, we're going to go to 3 decimal places, to the nearest thousandth, if I'm rounding in the middle of a problem. So the approximate value of tangent of 41 is 0.869. Now, we still need to figure out how to find x, but from this point forward, it's pretty straightforward. I can make my left side a fraction and go ahead and cross multiply. So I'm going to get 0.869x is equal to 6.1. Then I'm just going to divide both sides by 0.869. And I can't remember what it says to round to on our paper, so we'll go back and check that in a second. But 6.1 divided by 0.869 is approximately 7.02. We'll round to the nearest hundredth for now. I believe our units were inches. But again, this would be the process of solving a trigonometric equation, one that has sine, cosine, or tangent in it. Let's go back. See if we rounded to what they were asking us for. It says round to the nearest tenth, actually. So our answer over there was 7.02 inches. Well, if I round to the nearest tenth, that's going to be 7.0 inches. So our answer should be 7.0. Okay, see if you can apply this process to number 2. Okay, see if you can choose the correct ratio, see if you can solve the equation properly. We'll go through it and then we'll be done. Okay, so my reference angle is 20. 8.7 is my hypotenuse. MP is my opposite side. NM is my adjacent. And they're asking us to find MP. So that's going to be my x. Okay, I am looking for a ratio that uses the opposite and hypotenuse side, right? I want to use my x side, obviously, because that's the side I'm trying to find, and I want to use the 8.7 side, because that has a given value, right? The adjacent side doesn't have a given value, so no need to use or worry about that in this problem. So the ratio that uses opposite and hypotenuse is the sine ratio. So I'm going to get sine of 20 is equal to my opposite side, x, over 8.7. To solve this, again, you could go back to your Desmos calculator. I'm not going to go back there because I have another calculator pulled up. Sine of 20, if I round to 3 decimal places, is approximately 0.342. So 0.342 is equal to x divided by 8.7. Here, you could cross multiply. You don't have to. It would probably just be easier to think about it as multiplying both sides by 8.7. I was trying to make this a point, but that came out pretty poor. So multiply both sides by 8.7. 8.7 times 0.342 gives us approximately it says round to the nearest tenth. So we're going to get x is approximately 3.0 centimeters. If you're rounding to the nearest tenth, right, you end up getting something like 2.975. Well, this 7 is going to bump the 9 to 10, right? But I'm carrying that unit, so that bumps the 2 up to a 3. So 3.0 centimeters. Okay, that is going to do it for this video. I know I said I thought we were going to get to that diagram problem, but I'm going to cut it off here because we're over 20 minutes. We'll get to the rest of those problems in class. Hopefully you enjoyed this introduction to something you've probably never seen before. But we are going to continue to go more in depth into trigonometry. So as always, enjoy the rest of your day, and hopefully we'll see you next time.